Hello everybody, I'm going to talk to you today about thought experiments, and one very interesting thought experiment in particular. Anyway, this is about Oppy and me and Oppy. Yeah, we're the best of friends. Oppy barks and growls and he thinks he's a cocker spaniel, I'm not quite sure why. And I am just me. And I can be whatever age I want to be. I've got that privilege. Okay, that's so the machine whirred and whizzed and we finally arrived in the year 1935. And I said to Opps, today Opps, we're going to meet one of the most influential scientists of the 20th century. He's up there with Einstein and so forth. And Opps was really pleased about that. Oppy, do you know what a thought experiment is? What will civilization be like in 1,000 years' time? Maybe man has blown himself up with nuclear weapons, so no civilization will exist. Maybe man's gone to another planet. And of course I know Oppy, if you want to go to another planet, you want to go to Sirius, the dog star. Yeah, I understand that. But that's what a thought experiment is. It's talking about ideas and seeing how they evolve, you know? That sort of thing. You can't be proved wrong. What would happen if the world ran out of dog biscuits? Yeah, that would be a blow, wouldn't it, Oppy? No, we're actually in the time machine now, so my head's spinning around. And on the dial it's 1935. We're going to meet someone Opps called Irwin Schrodinger, and he postulated one of the greatest thought experiments ever in the history of science. Now, this thought experiment is called Schrodinger's cat. Now, when we met Irwin, Opps barked and growled and said, I don't like the sound of that, I can't stand cats. But I explained it was not a real cat, merely a scientific thought experiment about a cat and quantum mechanics. Quantum what? Opps barked. I told him that quantum mechanics deals with the state of subatomic particles and the like. Opps thought that was cool and then went on to say again, where does the cat come into all this? And furthermore, what exactly is a thought experiment? And I told him to shut up because we talked too much about thought experiments. And then Opps barked, hey, well, let's see what's happened to civilization in 1,000 years' time. We've got a time machine. And I thought, well, he's got a point there. We could go forward 1,000 years. But say the world then is so hostile. You know, just say the world becomes like Venus, a runaway greenhouse effect. And so if we went there, even for a fraction of a second, it wouldn't be a good idea. And Opps thought, yeah, that's fair enough. Anyway, we were going to meet Irwin Schrodinger. And here we were in the year 1935, and Opps barked to Mr. Schrodinger, hi Ernie, how's it going mate? Where's your milk cart? Okay, thanks my learned friend, although I do not own or drive a milk cart. Although a brother of one of my father's brother's uncle's cousin did once. But also Opps, my name isn't Ernie, it's Irwin. Oh, I'm sorry, my lord, Opps says to him. Actually, Opps was quite taken with Irwin Schrodinger. And then Opps said to Irwin, you're going to talk about a thought experiment with a cat. And I don't like the sound of that because I'm a dog and I don't like cats at all. Irwin replied, I know, my learned friend, it is not a real cat, but an imaginary one, and is part of a thought experiment I have made up which helps challenge contemporary interpretations of quantum mechanics, particularly the Copenhagen interpretation. He went on, you see my learned friend, I want to highlight to humans and dogs, like your good self, the dangers of applying laws and theories of quantum mechanics to much larger objects. Now, Opps was absolutely hooked, he was as good as gold. In fact, I've never ever seen him so well behaved. Opps then said, well, what is quantum mechanics? Irwin replied, it is a vast and complex subject. He went on to say, look Opps, if you offer me a deck of cards and I choose a card without looking at it beforehand, I know it is either a red or a black card, and when I turn the card over, what I see merely confirms my intuition that it is either a red or a black card. There's no argument about that. But if we were to think about subatomic particles, like an electron, you can never be sure where an electron is around an atom. It's in a sort of fuzzy cloud. So at any particular moment in time, you can never be sure where it is until you actually look at it. So the electron is in more than one place at the same time. In other words, it is in a state of superposition. Wow, Opps said. Now, Schrodinger went on, I wish to postulate a thought experiment about showing the dangers when one thinks of objects on a much larger scale. Suddenly Opps barked, I know all about thought experiments. Hey, Irwin, you're from Austria. Just imagine if in 4 years' time Germany was to start a Second World War. Oh my God, I had to shut Opps up then. That wouldn't go down very well in the Irwin Schrodinger camp. Now Schrodinger said to Opps, what do you know about radioactivity? Yeah, it's harmful rays or particles being emitted from an atom, which can be measured by means of a Geiger counter. Correct, said Schrodinger. In fact, there are 3 types, alpha, beta and gamma radiation. Now just imagine if you were to put one atom of a radioactive element, which has a 50-50 chance of spitting out a particle in the next hour, in a steel box, together with a cat and a Geiger counter connected to a phial of cyanide, in such a way that when and if the counter detects an emission, a hammer will make the phial break, releasing the cyanide, and the cat dies. Oh no. It was too late. Opps went up and bit him. He said, hey Mush, even though I hate cats, if you harm any cats, I'll be on to the RSPCA and the police. Schrodinger was shocked, but nevertheless very understanding about why Opps had bitten him. Look, my canine friend, this is merely a thought experiment to challenge contemporary thinking about quantum mechanics, and no cat is harmed in any way. He went on, you see, according to the Copenhagen group way of thinking, the thinking is that unlike the card trick explained to you earlier, where you know beforehand that the card is either red or black, when you look at things on the subatomic particle scale, things are not like that. You can describe the position of things as a wave function. That's all to do with fuzzy mathematics and that sort of thing. So when you think of something as a wave function, you don't know where the electron is. It can only be described in a mathematical way as a fuzzy thing. What you're led to conclude is that it's in more than one space at the same time around the atom. In other words, the electron is in a state of superposition of quantum states. Or, in other words, being in more than one state or place at any one time. It's only when you open the box can you confirm that a particle has been emitted, and then the wave function theory no longer applies because you can see which state the particle is in. And so it is then, and only then, when you know the true state of the particle, i.e. whether it has been emitted or not, and also, if it's been emitted, the cat will have died, and if it hasn't been emitted, the cat will still live. Again, the important and subtle point here is that, unlike the card experiment, you cannot know the state of the particle until you open the box, because its attributes can only be explained as a wave function. In summary, therefore, the important thing to remember about this thought experiment is that as the state of the radioactive particle before the box is opened can only be interpreted by mathematics as a wave function, and as the cat's life depends on this, its state too must also be described like this, as being in a state of superposition, because it is in a state of quantum entanglement with the radioactive particle, which leads one to the spurious conclusion that before the box is opened, the cat is both alive and dead at the same time. Wow. Plenty to discuss there. You could argue that the cat is alive and dead at the same time. No one can prove you wrong. Strange things happen in science.